Hi folks, it's been a while since I've been on here. This is the Sansui 9090dB I've been working on, and I had taken it in the house to check it out and make sure that there weren't any other problems with it. And everything sounded fine. However, when I engaged the bass switch, you can bypass the bass tone control or you can switch to one of two ranges. Whenever I did that, there was a noticeable pop in the speakers. And this concerned me because this came from out of state, and I want to return it to my friend 100% working and working condition. So I spent an inordinate amount of time trying to find out what was wrong. And finally, I reached out to the members of an audio forum, which I'm a member of, and somebody who is very familiar with this unit, has worked on many of them, said it's normal. Some are worse than others. And that kind of surprised me. Other people said, yeah, it's a design flaw. And I couldn't accept that. I mean, I thought Sansui engineers, and I believe still that they are cut above. And I was really surprised they would release a unit that did this. That wasn't loud, but it didn't seem right. So I set upon trying to find out why it was happening and how to mitigate or eliminate it. And I'm going to show you what I did there. Before that, though, I want to show you a short clip of a video I sent to the owner to demonstrate what was going on and why I wasn't shipping his unit back that day. Hi, Ray. I wanted to shoot a quick video to show you what's going on. I was getting ready to box your receiver up and send it off to you. And I wanted to check all the functions one more time before I send it off and make sure it's 100% because it's expensive to ship this thing. And I only want to have to do it once. So I was checking everything out, and I noticed that when you engage the controls for the bass, you get a little click. I didn't hear it outside in the bench because it's so noisy in the garage, what with the air conditioning and the test equipment and whatnot. When you gauge the treble, there's no sound, but when you gauge the bass, there's a small pop. Now I'm going to put this lapel mic by the speaker so you can hear what I'm talking about. And that's not normal. I want to find out what's going on with it. It affects both channels, which is very odd. And it only affects the low end, which is also odd because these are both part of the same circuit. This is absolutely silent. That makes a little pop. So I need to find out what's going on with that. Okay, so this comprises one channel of the tone controls. We have a bypass switch here for the low end, bypass here for the high end, and the signal is fed through this IC, which is a BA312. We'll be talking about that in a little more detail. The symbol makes it look like an op amp, but it is not an op amp. So anyway, basically this is bypassed, and you'll see that when this switch is here, we are bypassing the tone control. And it's bypassing these capacitors, and the signal just goes from here to here and winds up going through the output transistor here and then out. So why is it popping? The only thing that'll make that happen is if you have DC voltage getting in here, because this should be an AC circuit, and this is ground. You'll see that it's fairly well, the tone controls themselves are fairly well isolated from ground. So we need to see what's going on with our IC here. Now, as I mentioned, this is a BA312, and it's really more of a transistor array than a true op amp. And if we look at the schematic, which is a little wrinkled up, I spent a lot of time with this and a lot of time with these schematics. But you'll see basically what we have is we have an input transistor, and we have two transistors here that are wired up or configured in a Darlington pair. So we have three transistors and some resistors, and that's basically it. So our input comes in here, and these are the pins on it. So our signal goes in here, goes in here, goes in here, We pick it off at terminal 6 here. So I'm going to put this off to the side here. So this, and I'm sorry it's so wrinkled, I really should have printed up a clean one, but I hate to waste paper. God knows I waste enough as it is. This is what we have here. Now I wrote the voltages down, and although this channel doesn't show the expected voltages, it does show we have 2.2 volts here. I don't recall how many here. I did take voltage readings, notated them there. I have them here on a piece of paper. But basically, our problem is this. So let's take a better look at what's going on here. Our output has a DC blocking capacitor here. So we shouldn't have any DC at this point, but what happens is we have a feedback network here. Now this feedback network comes from the other side of the capacitor on pin 6 and goes through this capacitor here and this resistor to pin 3. And looking back at pin 3 here is our emitter. And we have 190 millivolts at pin 3. And we have a path through this resistor, and that brings it into here. And sure enough, I was measuring 170, 180 millivolts. And that's not a lot, but it's going to be amplified by this transistor, and it makes a noticeable pop. So, what do you do about that? What I decided to do was to add a capacitor right here to block the DC coming back from here, and then put a resistor to ground here that will bleed off any of the charge from this capacitor and this capacitor. The resistor alone won't do it, because remember, this is a current source. Okay, the emitter of Q1 inside here is going to act as a current source. And having a resistor to bleed that off doesn't work because it just keeps being sourced here. So we put a blocking capacitor here, and I use a 22 microfarad to try and keep this the same going back. And I put a 470K resistor here to bleed it off. What I found was about 15 to 20 seconds after turning it on, there's only a slight click now when you actuate the switch. Now I had to do this to both channels, and it worked. I don't like to modify circuits. I don't feel I have the requisite knowledge to do that, but this seems simple enough, and I was assured that they all did it and it was a design flaw. So I thought I'd give this a shot, and it made no audible difference. I looked at a square wave after making the modification on one channel, compared it to the other channel, and the response looked identical. So this hasn't messed anything up, and it did go a long way to mitigating that pop. So I'm going to take this inside, and by the way, let me give you a quick shot of the board here. Okay, so these resistors right here are the bleeder resistors, and on the other side of the board, all I did was lift R9 and R10 on the other channel and put this capacitor right there. I've seen Sansui lift the capacitor and lift a resistor and solder a capacitor to the free end to do what I did, and it seems fine. Everything works fine. So I'm going to put this together, take it in the house, and I'll show you how it sounds now. Okay, so I've got the unit set up in the house and connected to the speakers, and now when I actuate the switch, we don't hear anything at all. Now when I had headphones on, I could hear the slightest click, but now we have no more problems. And just to let you know, I'm going to take the lapel mic and hold it right by the speaker like I did last time. And that's it. So if you have a problem with this, if it's something that bothers you, and frankly, it's not a big deal. Most people live with it. You won't hear it when you're playing music, and it only does it when you actually move the switch. There's no other problems. It doesn't cause a loud pop. It just was not quite right. And I want to make sure this unit was perfect before it went back to its owner. So I just wanted to make this video to show what had happened, and I know I've been gone for a while because it really took me this long to figure out what was going on. So as always, I thank everyone for watching, and I like giving back to the community that's given me so much. Thank you much. Bye-bye.